Okay, here we go. All right, today our objective is to graph tangent and cotangent. Graphing tangent and cotangent is easier than graphing sine and cosine. If you look in your notes, eventually we're going to get to this spot, but for right now, I'm sorry, not that spot, not that spot. Eventually we're going to get to this spot, but for right now, I just kind of want to sit and look at the unit circle for a little bit because it's beautiful. Circle of life, here we go. You know that the tangent of theta is equal to the y value divided by the x value. And that's what I want to focus on right now as we look at tangent. You're going to discover why the graph looks the way that it does. If you take y divided by x, what do you come up with at 0? What do you come up with if you do y divided by x? Everybody see you get 0 if you take 0 divided by 1? Then what happens if you take 1 divided by 0? Undefined. So therefore, tangent is 0 at 0, and then at pi over 2, it's undefined. How about at pi? 0. How about at 3 pi over 2? Undefined. And then you can see it's just going to kind of cycle between 0 and undefined over and over and over again, right? How about another one? We got positive and positive. We've got negative and positive. We've got negative and negative. And we've got positive and negative. So if I take y divided by x, do I get positive or negative here? Positive. So tangent is positive right away, so it sits above the x-axis. Then, negative. You know, here's what's interesting about tangent, and it's the first and most important thing that you need to know and understand, is that when you look at tangent, it goes from 0 to undefined in the positive, and then from undefined to 0 in the negative. And if you look, doesn't it repeat that same cycle here? Look, as I go this direction, I'm encountering the exact same spots, aren't I? The exact same routine. So it turns out that instead of tangent requiring a full circle to repeat itself, it just needs half of a circle. So that's why when we look at tangent, the first and most important piece is to determine the period. And the period, instead of 2 pi divided by b, it is 1 pi divided by b. Tangent does not require a full 2 pi, just 1 pi. Yes. Sure, yep, just write y is equal to tangent of bx. We're not going to do a horizontal shift with this one. We're going to keep it simple and just look at a change of period. So let's discover what the tangent graph looks like. We have a couple pieces already. First of all, we know that the period in this situation is simply pi. So what I'm going to do is on my graph here, I'm going to mark off pi, and I'm going to mark off negative pi. Sine and cosine, how many parts did we divide that into? Why 4? Because it takes 4 quadrants to repeat itself. How many quadrants did this take for it to repeat? Just 2. Everybody see that? So therefore, when I divide tangent up, I'm not going to divide it in 4 parts. I'm just going to divide it into 2 parts. We're also going to think about the tangent value. You told me that the tangent of 0 is, and the tangent of pi is, see how it's 0 at the period? Like when you rotate a full period, you get to 0. Rotate a full period, you get to 0. At all the period values, it's 0. What happens halfway in between? Undefined. So therefore, as we graph this, we are going to mark 0 at the period values. And then you told me that halfway in between, it's undefined. The way that we show that something is undefined is we draw a vertical asymptote. Remember drawing those before, right? And they come back again. And so, for the last part, we just want to figure out then what the shape looks like. It sits among that, but what does the shape look like? And tangent is y over x, which is the same as slope. Somebody describe for me the slope right here. How about right here? Really small, right? So the value of tangent starts at 0 and is really small, but then what happens to the slope? Yeah, like what would be the slope about here? A lot, right? A lot. I mean, it's going to, like the slope, as you get closer to the vertical line, like the slope actually becomes close to like infinity, doesn't it? I mean, eventually it's going to go almost perfectly straight up and down, right? So the tangent value goes from small to really, 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 really big. And so therefore, as you mark your graph, it's going to look like this. It's going to start small and it's going to get really big. And it does that same thing on the other side, it just is negative. And it repeats that shape over and over again. Does that look like a shape you're somewhat familiar with? The cubic. The difference is the cubic flattens out at 0. This doesn't completely flatten out. We will not do the horizontal shift. Yep. All right, the cotangent graph. The same thing. We have a period of pi. So I'm going to mark pi, or mark negative pi. By the way, I'd say about half the students third hour were able to get their assignment done today in class. We did. I marked out the period. Why again did I divide it into 2 quadrants? Yep, exactly. All right, now let's look at cotangent. How is cotangent different from tangent? It's the reciprocal. So what do I get if I do the reciprocal of this? Undefined. Everybody agreed? And what do you do if you get the reciprocal of this? So it's going to switch values between 0 and undefined with tangent, isn't it? So let's mark that. We'll go back to this spot. And at our period values, right here, we're going to put undefined spots, our vertical asymptotes. So instead of putting 0 there, we're putting vertical asymptotes. What do you think happens halfway in between? It's where it crosses the x-axis. And the shape is slightly different from tangent in that it starts up and it finishes down. Sure. At this point, I'd like you to take out this sheet. This is the sheet that you're going to get to use on your test. First of all, you can see that we've already talked about the graphs of sine and cosine. And now you can see the graphs of tangent and cotangent. Now, here's the part that really, really gets to me, is when I have you guys on the test determine the period, you do 2 pi divided by b for sine and cosine. Guess what? A bunch of people also do 2 pi divided by b for tangent and cotangent. It is not 2 pi, is it? It's 1 pi divided by b. And then you wonder where it starts. Tangent's equal to 0 at the period. Cotangent's undefined at the period. Those are essential pieces that you want to make sure that you know. Some people say after the test, if they don't do very well, they're like, well, I never learned how to read that. That's the measure of you as a student then. You don't know how to read the sheet. So you might not get a good grade. So let's figure out what that stuff means and work through it, okay? All right, let's do a couple examples. You guys will do really well with these, and then you'll have time to get your assignment done. Sketch the graph of the following functions. All I'm going to ask us to do is determine the period. What is the period of that graph? 1. So I'm going to mark off 1 and negative 1. Now what? Good. I heard a half and negative 1/2 because we're going to divide it into 2 parts. That's the first step. You did a great job. Now what? Well, where do I put my zeros and where do I put my asymptotes? Zeros at the period. Good. What did you say there, Luke? Yeah, negative 1/2 and positive 1/2 is where the asymptotes go. And then, do I start down and finish up or start up and finish down? Start down and finish up. That's it. Can we get these points on the test? Next one, what's the period? Pi. Divide it in half. Pi over 2. Negative pi over 2. Did the zeros go at the period, or did the zeros go halfway in between? Period. Thank you, Miss Ella. We do have to worry about the negative 2 in that it is negative. So I don't care about the 2. The 2, if you wonder how it affects it, it creates a vertical stretch. It would actually make it so that as it passes through the x-axis, it would have a slope of negative 2. You don't have to try to show that, but that's how much it stretches it. You know what I mean? So what do you think it does to it, Marissa? Flip it. So instead of starting down and finishing up, we're going to start up. We're going to finish down. You can see, I drew these a little bit steeper. Okay. So Marissa's made a great statement, but I want to qualify what she stated. She said it's just like cotangent. Yeah. So it is in that it has that very similar shape, but just notice that it's not. Notice how in this situation you see 2 revolutions of the graph, but here you see 3. So very different in terms how they're shown. If you were to slide it over to the right, then you'd get the same thing. So it's just like cotangent in that sine and cosine are almost identical, right? With a horizontal shift, yes. Exactly, and you have just now proven one of our trigonometric identities. There you go. Nope. Just to be clear, both graphs have an infinite number of graphs. We just show that many. Okay? All right, last 2. Cotangent of x over 4. What's the period? Pi divided by 1/4. Miss Avery says I multiply by 4 and I get 4 pi. Divide it in half to get 2 pi and negative 2 pi. Now what? Now instead of putting the dots down right away, I put the asymptotes down right away, right? Asymptotes at all of those period spots. And then undefined halfway in between. Where do I start? And you guys, it's definitely supposed to get close to the asymptotes. A lot of people draw their graphs like this. I don't mark it wrong on the test, but without a doubt, that's not what we're trying to do. It's trying to follow like this. It really is. So it's getting close to the sides. Last one, then you have time to work, period. I take pi and divide it by what? Pi over 3. So multiply by 3 over pi. I get 3. Gav, how's your foot? Put my asymptotes at the period. Does cotangent start down and finish up, or start up and finish down? Starts up and finishes down, but it's negative, so it's going to start down and finish up. Which, to confirm what Marissa said earlier, that makes it a tangent graph so long as you then shift it right or left. And that's that. I'm not kidding when I say you definitely have time to finish your entire assignment. Test on what day? Tuesday. So we do have one lesson yet to complete, and we're going to spend some time doing some graphing, and hopefully you'll be good to go.